Okay, my name is Evan Scheibel for CG Toots Plus, and in this tutorial, we're going to take a look at the water space warp in 3D Studio Max. Now, you can see here on the screen, I've prepared a few different shots for the example here for the tutorial, and I just wanted to show you guys just a few different angles of this scene and this specific use of the water that I made here. So in this one you can see that the water looks really nice and realistic, and but I want to show you also a night shot of the same scene, or at least an evening shot, because this really accurately demonstrates the refractions, the reflections, and the blurred refractions and refractions that we can get, as well as the caustics, at least mildly in this scene. And then also we've got another angle this way. So this is some of the things that we're going to look at for this specific tutorial, and the way we're going to go about this is for both the first half of the tutorial we're going to look at theory and really get to know the space warp and how to use it, and not only how to use it, but I really want you guys to understand what you're doing as you use it, so that it's not just what to do, but you can understand how to do it, and what does what, and not just knowing, but understanding. And so that's what we're going to do, and we're going to, for the second half of the tutorial, we're going to apply all of the theory that we learned in this specific scene here, and we're just going to recreate the little water patch there. And okay then, so let's get started here. Here we are in Max. And the first thing we want to do is create the space warp. So let's go to our create panel, and then we'll go to space warps, and we'll hit the flyout menu and choose reactor. And then we only have one option, and that's the water space warp. So let's drag this out, and I'll just bring this out here, about so big there. Okay, and before we go too far, I want to really emphasize one thing here, because you can see that we're dealing with, especially in this scene, we're dealing with light sources, and I use Maxwell render for mostly, as pretty much my main render, but especially for scenes like these. And dealing with Maxwell render, or Indigo, or Lux render, or V-Ray even, or Mental Ray, if they're set right, you're dealing with physically accurate light sources and physically accurate things. And if you're doing architectural visualization especially, you're most likely going to be building most of your things to scale. And what that means is you're going to have your units set up properly in Max, because as you can see here in our pool, we have a certain wattage light bulb, and they're going to behave just like that equivalent light bulb would in reality, which means they're only going to light a certain part of the scene. So we have to have our scene built to scale in order for a 100-watt light bulb to work like a 100-watt light bulb actually would, if you understand what I'm saying. So in order to set up our units in Max, we'll come to the Customize menu, and we'll go to Unit Setup. Now I have them set to metric right here, just because. But you can set it to US Standard. You've got all these different options here. And then if you come to US Standard, you've got all these different things here. But for this right here, I'm going to keep it in metric. Okay. So what we're going to do is just really fast go through the theory of this plugin and go through probably every setting that there is in it, so we can really see how it works. Okay, so right now what it looks like is just kind of a plane that's with a subdivision modifier, and essentially that is what it is. The only thing is, though, if I render this right now, it's not renderable. There's nothing we can see in our renders. We'll go through how to really fix that later, but for now, let's just move forward with what we have. So in our edit panel here, we have a bunch of different settings, and like I said before, our size is pretty important, because right now it's 30 by 30 meters, and that's pretty decent size. It's kind of big even for some scenes, but it all depends on what you're making. So in this case, it'll be fine. But probably the most important spinners in this entire menu are the subdivisions X and Y. Now, the reason for that is when we're dealing with something like this that has a lot of dynamic motion and isn't based on hand animation, we're going to have a detail problem if we have a low subdivision level. What I mean is, because we're going to have water ripples moving through this mesh, we need a very high subdivision level in order to get the detail that will make it look nice. Otherwise, we're just going to get rigid edges and you'll be able to see triangles in there, and a lot of artifacting and things like that, which we obviously want to avoid. So what we're going to do is, for 30 by 30, I think probably a good subdivision level would be about maybe 45, 50, 55, somewhere in there. So in this case, let's just go with the highest level that we think would be appropriate. And it's really important to think that through based on your size, because if you don't have enough subdivisions, then you're going to have horrible detail. If you have too many subdivisions, you'll crash your system, and it's pointless to have too many, and it's not beneficial to have not enough. So I think about 55 will do us fairly well for this mesh here and what we want to do with it. So it looks pretty good. And another thing we want to do is look really quickly right off the bat. Let's just make this renderable. So what I want to do is I'm going to move this up off the grid just a little bit and come to my top view. And what I'm going to do is create a plane. Okay, and I'm just going to drag this plane out just relatively the same size as our grid. And then I'm going to come back here. Now, there's a couple tricks that we can do to get these to line up perfectly as it comes to position. But right now, all I'm going to do is zero this out on X and Y, and then zero my plane out on X and Y as well. We'll look at that in just a second, but first what we want to do is realize that in essence what we're going to be doing is transferring all of the motion from this space warp to this plane. That means all of the ripples, if there's any splashes ever, or anything that we're doing, we're transferring all of the information from here to here. So we need to keep that in mind because we don't have a subdivision level that's nearly high enough to be able to work accurately. So what we want to do is subdivide this so it matches up pretty well. So let's just grab our length segments and make it 55 and our width segments 55. But you're going to notice one thing too right off the bat is this mesh is triangulated while this mesh is quads. So what we want to do is add a subdivision modifier to our plane in order to triangulate the mesh. So that's what we're going to do. Let's just go to our modifier flyout here, and we'll just choose the subdivision modifier. And default settings are fine because all we need it to do is triangulate that mesh. So that looks fine. And now, what we want to do is get our water and our plane to line up on the z-axis perfectly. And the easiest way to do that is, in this case, just to zero it out. But let's say we can't do that. Let's say, like in our scene that we're going to be working with, we have a pool. Well, let's say it's up here a little bit, and we need to get an exact we need to line those up perfectly. Well, the best way to do that is just to come and in this case we'll choose our plane Z position, and we'll copy it to our water's Z position. And just hit enter, and it's lined up. There's also a Max script that does that based on positions, and it's pretty easy to write. So, but in this application, this is quicker. So we'll just do it this way. All right, now we need to remember that this is based on Reactor, on Havoc's reactor system. So we need to have something to drive the animation of the water. In the scene that you saw as the preview, I used beach ball, and let's just follow that same principle here. So we'll create a sphere, drag that out, bring it up and over, and I'll just zero it out on X and Y so it's right in the middle. Alright, so what we want to do now is give this some physical properties. And the first thing to do, the first step we need to take to go that direction is to add this to a rigid body collection. So if you don't have your reactor toolbar docked somewhere in your user interface, just go ahead and right click somewhere in your menus and make sure reactor is ticked, and then dock it somewhere or float it somewhere or whatever you'd like to do. And make sure you have the sphere selected, and then come down here and hit make rigid body collection. And that will, with whatever we have selected, make a rigid body collection out of it. So in this case, we've just got our sphere added. And you can also, with the rigid body collection icon selected, you can come over here and you can pick different pieces of geometry individually, or you can add them from the hierarchy. So that's also another handy way to do it there. So let's select our sphere and then come in our reactor toolbar to our physical properties dialog box here. And what that's going to allow us to do is add mass, friction, and all the different physical properties to our sphere that we're going to need for our animation. Now, before we go too far with this, one thing we need to understand is just a little bit of how the physics of this simulation will work. And so let's come into our water space warp dialog here, and let's look at just a few things. Mainly at this point, density and viscosity. Now it's important to understand those, as I know a lot of people don't, because they're kind of scientific terms and they really only deal with fluid simulation, which a lot of people don't get into too deeply. So let's just look at what these mean and how they're going to affect our simulation here. Our density is pretty much, in layman's terms, how thick the water is. So if you take honey, that has a higher density level than water. And what that's going to do is affect the buoyancy of the objects that we drop into our water. To really understand how that works in an easy way is an object that is less dense than the water will float, and an object that is more dense than the water will sink, at least to a certain degree. And that also depends on friction and elasticity within our rigid body parameters as well. But that's just an easy way to understand the density. It's just pretty much how thick the water is. Now viscosity is a little different. Viscosity is how, what's the best way to say it? Viscosity is how resistant the fluid is to flow or to movement. So the more viscous the fluid is, the more resistant it will be to movement as it interacts with other objects. And if we were dealing with pouring systems, that would be much more evident, because the higher the viscosity is, well, the more kind of gooey the fluid will be. Like honey is more viscous than water, and whatnot. So, and you can always tell a cheap simulation because it's really blocky and it looks like sludge rather than water. It's because whoever did the simulation didn't really understand viscosity and density settings of their simulations. So that's just a really quick, in a nutshell, way to understand density and viscosity. So with that in mind, we'll keep in mind that our density is set to 1, and back in our sphere we'll set our mass, because it's a beach ball. Well, let's demonstrate something first. Let me set this to 10. Okay, and I'll set my friction to 0.5, and I'll set my elasticity, because it's supposed to be a beach ball, to like 0.5 as well. Now, within the Havoc system, physically accurate settings are usually between 0.1 and 1. And if you go out of that range of settings, you'll get warnings from Havoc that tell you you'll get physically inaccurate and unrealistic results from your animation. But unless you're going for a certain specific effect, it's not really beneficial usually to go outside of that range. But for this demonstration, we're going outside of that range, and we'll probably be outside of it for the most part. So our mass is set at 10, and if I create an animation at this point, what you'll see is, now we don't have to add our world space or our space warp to the Havoc system because it automatically is. So we don't have to worry about that. But at this point, if I just see, what happens is it drops in and sinks low and then comes back up. And that's pretty good. And this is pretty equivalent to what RealWave does in RealFlow. Pretty close to the same concepts. So you can see it looks pretty realistic, and it sinks down, pops back up. We don't get any splashes because that's a whole nother tutorial, a whole nother system in and of itself. But it looks pretty nice as we have it right now. So that's the reason it sinks down and bounces up so much, is because our mass setting is about 10 times higher than the density setting of our water. So let's set this to 1 and we'll see what happens. We'll create the animation again, and we'll come through, and now you can see what happens. It looks more like a beach ball now. And if we set our friction up to, let's say, 3, And we'll come to our beginning, we'll create the animation again. Okay. And you can see now it just bounces a lot. And you can get that, we get that jitter because it's fighting with the water now. So we want to keep our friction setting kind of low, especially for a beach ball. If you've ever seen a beach ball thrown on the water, it kind of rolls around and moves around quite a bit because there's really no friction between the beach ball and the water. So that's going to be pretty decent settings right here for a beach ball. It looks pretty nice if we just scrub through it. Okay, but I want to demonstrate a few more things, so I'm going to go to 10. Really quick, do this again. Alright, and that should do it. Yeah. Alright, and I'm going to zoom right in here now, and I want to demonstrate one thing here. You can see that there is movement. If you look closely, there is movement, but it's not too much. And if we render this right now, there's no movement there at all. Let me change my wire color here so we get a different color. Alright, so what we want to do is come into our water, and we want to mess now with the wave speed and the min and max ripple. Now what these are, it's pretty self-explanatory. The wave speed is how fast the ripples and the waves will move away from the point of impact or the point of motion with the different objects. So in this case, we have this ball falling into the water, and the wave speed is going to be how fast the ripples move away from the point of impact. Now you can see it's set to 12 meters right now, and this is another really important reason to work in actual units, is because we can see that our size for x and y is set to 30 meters, and a wave speed of 12 meters. It's going to take, no time at all for the waves to just zip out from the point of impact, hit the wall, come back, and it's just going to create chaos, which you can see they're really going fast. So if we set this to about maybe 3, you'll see now, once we recreate this animation, you'll see now it moves a lot slower. That might be a bit too slow, so let's set that to maybe 7 or maybe 5. Set it to 5 for now. We'll recreate the animation, and you'll see that that adds a lot of extra detail and realism. Alright, so if we just play that through now, if you can see it, that looks a lot nicer. It might even be able to go a bit faster, so let's say 9. And that's pretty good. Okay, and now the wave height, or the min and max ripple, is kind of the sizes of the ripples. That's kind of like a clamp for how the animation will be affected in terms of the ripples. So right now it's clamped to 12 meters. That means the waves won't reach a size bigger than 12 meters, which is pretty big. So you don't really usually have to mess with that. But I'm going to actually just make it outrageously big so that there's no kind of cap for how big they can be. And that's handy because there won't be any funny things going on then. The small is usually, you could just set it to 0.1 and you should be fine, because that just allows that to move naturally. And see, you can see now we've got a lot of and you can see now if we still have nothing here though. Okay, and everything else is fine. I'm going to clear these keyframes and I'm going to recreate the animation. Okay, and now you can see we've got that going on, but the reason we're not seeing it represented in our geometry is simply because if we come to our plane here, we need to bind this plane to our world space modifier, and that's going to transfer all of our information. So if we grab our space warp and drag it and bind these two together, and then again just take this, paste it here, and what we've done is we've just used this little tool here and bound those two things together. And now what that's going to do is take all of the information, like we talked about before. It's going to take all of the information from our space warp and transfer that to our geometry via a world space modifier, as you can see here. And now we have this scale strength. But if we come in here and if we again recreate the animation, you can see now if we come in and if we render this, You can't really tell too much because we don't have very good lighting, or any lighting really at all. You can see that there is now some representation in our geometry, but if we use our scale strength and bring this up to say 3, you'll be able to see now that if we render this, you can definitely see that everything's working out fine and exactly how we need it. So I'm going to come out to my front view and I'm going to create a light, and I think in this case I'll just create probably an Omni, and drop it in here and drag it up. I'll just position it right above here. Okay, and I'm going to enable shadows so I can see that here. And then what you're going to see now is that we have some representation of what we're going to do. Let's just to be safe, recreate this. And bring this over. Okay, so you can see here that we've got some ripples in our water. And if we even come into our plane and scale this up more, just dramatically, so we can really see, you can see now we've got the ripples there. Okay, so that's looking pretty decent. The question now is, how do we make it look real? Because now it's just blue, and it obviously isn't looking anything like we want it to. But we've got these nice ripples that they move out at a nice speed, everything like that, and they even kind of bounce off the walls here. So that looks pretty nice. If we render this, it looks good. One other thing that we can cover before we go into shaders is the if we come into our water, we'll see that we have this landscape feature. Now what that is essentially is it creates a container for our simulation. So if we come in here and we come to our geometry, and let's create a tube, and we'll just drag this tube out and bring it up, and just position this so it's usable here for, like, let's say a swimming pool or something like that. And what we want to do now is make it so our waves bounce off this wall. So what we'll do is we'll just select it and add this to our simulation, create the rigid body, or actually we'll just grab our old rigid body and we'll pick our tube, and then we'll come into our water and we will activate landscape, and just by ticking the box, then we'll choose this little none here, and what we're going to do is choose our tube. And now when we create the animation now, hit yes, and what's going to happen is, see, what happens now that we added that is we need to make this a concave mesh, because if you look, it just kind of bounces off. It's seeing this as a solid piece of geometry. So with our tube here selected, we'll come back into our properties settings for our mass, and we'll come down, we'll leave everything the same because it's not going to be really used too much, but we'll change this down here to concave mesh, and that's going to give Havoc the information to understand that this is, you know, a hole here, that this has concave information. So we'll recreate that animation now, and now you'll see that it works fine. And you'll also see what happens is, let's, again with our plane selected, we'll scale this up huge, let's say 20. And what's going to happen is, you can see that our simulation is bound inside of our environment here, inside of our tube. So that's really handy for effects that need to have water that's in like a glass or something like that, or something like that. And you can see that it's really handy because it just contains our simulation inside that little that container there. So that's really handy for that. So now, how do we go about making this look real? I'm just going to delete our thing there, and let me really fast show you how to do. Well, actually, I'm just going to go right to it. I'm going to go to I'm going to switch my renderer to Maxwell, simply because that's really the only renderer that I can, besides RenderMan, that I'm good with shaders in. So with Maxwell selected, I'm going to come into my material window here, And with the first slot here selected, I'm going to choose a Maxwell material and then update my preview so you can see that we've got a material there. Alright, and what I'm going to do is load a shader actually that I used actually for the preview, and I'll go through a few of the settings. And it's called Displaced Water. I actually got it from the Maxwell Materials library online, and then I've just kind of edited it for what I needed. And so if we hit render right now off the bat, we're going to see that we get just Maxwell giving us its default settings and everything. And the good thing about Maxwell is you can continue to work inside of Max while Maxwell renders. So what I'm going to do is just stop this render, and I'm going to apply this to our plane. Alright, and I'm going to hit render, and then I'm going to let Maxwell calculate, and I'm going to show you some of the settings. Oh, one thing we have to do is locate the IOR file, and so we'll come here. And I'm actually going to pause the tutorial while I do this because I have to go through all my program files and stuff and documents, and a lot of that stuff I'm not at liberty to show. So I'm going to pause this and I'll be right back. Okay, so while Maxwell is working on this render here, what I want to do is just show you really quickly the basic settings that I have for this shader. Now, I want you to understand that these are not specific settings for Maxwell render. All of these shaders and these settings can be used, you know, not the shaders themselves, but the settings that are used and the techniques that are used within this shader are translatable throughout anything that uses shaders, which is any renderer on the market, except for a few that use their own language and procedurals. So what we have here is just, you can see right here is the color information. Now, it's important to understand when adding shaders to water specifically, you're not going to set up the color information like you would for, let's say, just a diffuse color for a plastic or car paint. Now, the reason is, majorly what water does is just reflect the scene around it. So you don't really have too much color information in the water itself because it gathers that information from its environment. So as you can see here, I just have really pale aqua type colors. And the biggest thing with water is getting the transparency right, and that's pretty easy in Max with the material editor, especially if you're using Mental Ray, which has the ArcViz has water and window materials built right into it, so you can use those and customize them as you need. Another huge thing is, if we come down here and look, is the displacement mapping. Now, an easy way to get displacement map for water is just to go online, grab a picture of water ripples, or just water in general, still water, whatever it is you're looking for, grayscale it, and use that as a displacement map. There's also other ways to do it. You can use normal maps as the same. There's just numerous ways to go about that, and there's a really handy little application that you can get for Photoshop called PixPlant. It's a plugin as well as a standalone little application that will create shaders for you and all the maps that you need from an image. Really highly recommend that. But it's actually pretty easy to do, and the displacement is one of the biggest things. And you'll want to use displacement, not bump mapping, because in this case we want the mesh to actually be displaced. We want the vertices to be moved. We don't just want to see an illusion of that. It's handy to take that extra time and do the extra work to actually create the displacement map. I'm not going to go into that in this tutorial because you can find tutorials by the bucket load online for how to create displacement maps. So that's just the basics of creating a shader for the water. So let's check in on Maxwell, and you can see it looks pretty nice. We've got the displacement map working alongside of our ripples, which is making a really interesting natural kind of random effect, which is really nice and what we're going for. So this is looking really good. We can let this render for a while, but in this case what I'm going to do is just go ahead and stop it, and that's looking nice. Now, because we just have this sky here, we're not going to see too much color information in our water. Like I said, all it does is water usually is reflect its environment. So I'm going to come out of this and I'm going to close out all of this, and I'm going to bring up a second instance of Max that I have open, which is the scene that I used to create the tutorial example. And what we're going to do is just really briefly, I want to take you through recreating the water for the pool. And so let me select this and delete all of that. And now the modeling is really simple. I'm not much of a modeler, so everything that you see here is I modeled all this and did it all, but except for the hammock. But it's really simple to do. There's tons of tutorials on modeling right here on CG Toots, so you can take those techniques and you can make this swimming pool yourself. It's pretty easy. The shaders, those are all done in Maxwell. Everything's procedural in Maxwell, so pretty easy to do there as well. But what we're going to do is concentrate on the water. So what I'm going to do is come to my top view, and we've already covered this, so I'm just going to show you the practical application of what we've already learned. So I'm not going to go through explanations all over again. So I'm going to create my space warp and drag this out. And this is where the little trick that we use for our position really comes in handy, is because it's not going to be set at the 0 axis on Z. It's going to be, way up here. Okay, and so what I want to do now is just pretty much subdivide this the way we need it. So let's say 60 by 60 again. Make it nice and detailed. And then I'm going to create a plane. Come to my top view. Create a plane. And again, this is just demonstrating what we've learned, so I'm going through it pretty quickly, purposefully. I'm going to drag this quite low at first, because what I'm going to do is go through my water, and I'm going to set everything up exactly how it needs to be right off the bat. So I'm going to set my landscape to the pool. Everything else should be fine. Check our size. We'll set our wave speed to about, let's say 7. Our density viscosity is fine. We'll set our depth to a little more here. And then I will clear any keyframes that might have been kept over. And now what I'll do is grab my bind to space warp tool and just bind these together. And then I'm going to grab my Z space, or my Z axis information, paste that into plane, and there we have it. And I have some shaders in this scene already set up for Maxwell. The same shader we just looked at is the one I'm using here. Practically the same. I don't think anything's changed. So I'll just drag that out to the plane, and then I'm going to make sure that everything's set right here, and unhide all. And I'm going to come to my first frame, and I'm going to hide this cloth here. This is just for decoration. And I'm going to come down here and recreate this animation. Okay, and let this go. Alright, and now we should have a pretty nice animation, and we'll come into our plane and we'll scale this up by, let's say, 4. So now it's looking alright. We might do one more quick little setting here, and this is just to give you some insight into the problem solving side of using it in an actual scene. You can see our max ripple, let's just jack that right up and bring this one down to like 0.1. That gives it a really nice amount of just room to be able to move. We'll recreate this animation now. And we've got that. Oh, one thing we didn't do is subdivide our plane properly. So, and that's why we're getting our thing there. And now you can see we've gone too far with our plane already. So if we move this down, it converts it to an editable poly. right off the bat, I think. So if we come in and grab our plane. Okay, here we go. So let's subdivide this by 60 and by 60 and recreate the animation. That's why we were getting such rough animation there that you saw. So now it should look nice. Yeah, there we go. That looks a lot better. And it's reacting with the edges of our pool really nicely. So let's grab an angle here. Let's say right about like this. Looks good, and we'll create a camera from the angle, and we will bring up our render settings. Make sure it's set to camera 2, and everything else is good. And I'm going to go through just my environment settings for this evening scene. All I have is my latitude and longitude set like so. You can see that. And I think this is somewhere in Brazil. So if you go through here, you can find somewhere in Brazil. And it's actual real time, so whatever time it is here in LA, well, it grabs that time and it uses it for Brazil. So that's how that works there. Okay, so I'm going to let this render here. And that's pretty much it for this tutorial. Let me let this come through, and I'll pause this and let it render a bit, and when I come back I'll do some little closing observations. We'll look at the render and call it good. Okay, so while Maxwell is working here, I want to just make a couple real quick closing observations. One is, as you can see in Maxwell, we've got the caustics here. Now that's what I was speaking about when I talked about the physically accurate settings and stuff like that. Because the way the water moves, you want to have accurate caustics because that adds a lot to the effect. And the way to do that is it's all built into the shaders. And it depends on your reflectance and your refraction values. And also your render settings. Make sure you enable, like if you're using mental ray, make sure you enable like final gather, things like that. Just and have everything enabled that you need to in order to do that. And when it comes to this Maxwell scene, you won't get an atmosphere and a lighting setup like this by default. I had to create custom lights and an atmosphere and things like that. But Maxwell can yield pretty good results without having to do too much customization yourself. So that's just some final things I wanted to point out. And thanks for watching. And if we let this render for a lot longer, we would get rid of this graininess here, and that's the caustics actually being generated by Maxwell from this light. So anyway, I will upload this image maybe on my website, which is evanscheibel.com, or I'll just send it over and they can upload it with a tutorial, or neither one of those things. But anyway, thanks for watching, and stay tuned to CG Toots Plus for more tutorials. And I hope you learned something. And don't just comment on this tutorial. Put some links to what you guys make with the knowledge you gain here, because it's great to see that you guys like the tutorials, but it's even better to see what you make with the knowledge you gained. And I hope it's not a swimming pool with blue tile and a beach ball. I hope it's your own creations. All right, guys, thanks for watching, and I look forward to bringing more tutorials your way.